into manufacturing, right? So gasification exists all over the world. We do it all the time, and we make synthesis gas on purpose for that reason. What we're talking about is a robust form of this technology, which has been in development probably since the 1990s and has reached a kind of a Gen 2 level, which is commercially ready. It's being used today. And essentially what that does is it allows you to put anything in there, right? Anything in there, right? So mostly we want the organics, but today, for instance, you have a juice box, there's plastic, there's paper, there's foil, there's a whole bunch of materials all connected there, never be recyclable in what you guys are doing right now, but you could throw that right in there. So this robust technology exists, and what this does is it allows us to think about recycling in a different way, and we'll get there. And then regenerative, okay? So today, folks are using robust gasification to produce fuels. Like the airline industry is doing this right now. They have just built a plant. The airlines are investing directly into this. They have a plant in Nevada right now that's taking municipal solid waste and producing jet fuel. It's part of their sustainable aviation fuel program. From the packaging world's industry, perspective, there are folks that don't like the idea of taking something that might have come from a fossil source and burning it in any form, right? So this is, this kind of violates the notion of circular economy. So the regenerative part here is a commitment of using this technology not to produce fuels or energy, but to produce chemicals for manufacturing. That's an important thing for our industry, but frankly, to the extent that we would use it for energy, that's clean coal technology, actually. When you heard about clean coal, gasifying coal and then burning the syngas, because that burns very cleanly. So let's get into this. All right, so up here is like everything you guys hate, I'm sure, right? So, we've got PFAS, we've got all kinds of adhesives, metals associated with plastics, foils, fitments and pumps, things that have springs and metal components in them, chlorinated, halogenated polymers that, incinerators don't want, metallized films. So all of this stuff kind of creates a problem. All of this stuff can go into this process. So when we talk about we're at 41%, you need to get to 75%, this is how we get to everything else. All right, so in terms of looking at methods of recycling, right now, when we say recycling, I kind of disagree, right? So when you recycle plastic and you take it, you grind it, melt it, and reuse it, it's degrading that polymer. And we see in the, only PET right now has an FDA-approved process to make it food grade again. But I get from my own graduates working for beverage companies is that the rPET that they're paying twice as much for than virgin is discolored, produces pinholes. The quality is not very good. We see that a lot. So anyway, I would say that the recycling, what we're talking about today, is closer to reusing. We're just reusing it in a different way. And ultimately, those applications are downcycling. And inevitably, every gram of that material is going to end up in a landfill if we don't have something else to do with it. So that's material-specific recycling is what we're doing right now. And because of that, it puts a tremendous onus on our ability to sort these materials, and we're terrible at it. I mean, over decades, we've proven we just are not good at it. So moving up this spectrum, we have material-specific processes. We have some processes coming out today that are they're a little more robust, but aren't really there. A very popular one is pyrolysis. You've probably been hearing about. The petrochemical industry is very interested in this because they have assets, they have refining assets, and the pyrolysis oil is what they're after. However, pyrolysis is a process that we have traditionally used to make char, right? Like charcoal from wood. So we're after the solid output of this. The liquid and the gas output is too little. It's actually syngas, but there's too little of it to do anything with. So that gets burnt to run the pyrolyzer. Today, for the recycling, they're after that pyrolysis oil. But because you get char, oil, and gas, the yields are very low, right? So we're doing all this, and on top of that, they're very specific. This is a process that has to be oxygen-free. So a lot of materials like the biomass or PET, they have oxygen in the molecules themselves. So right now, that industry pretty much just wants polyolefins. They want the polypropylene, polyethylene. So it's a little more robust, but it doesn't really get us there, and the yields are pretty low. All right, then in terms of robustness, one of the key technologies is plasma-assisted gasification, and it's something that we're working with right now. So this is the big vision right here, right? If you forget everything else, this is it, right? So basically, we can take the mixed waste, you know, and get it into the process that's an image of a version of a robust gasifier that came out of hundreds of millions of dollars of research out of our national laboratories, originally intended for and used today for stabilizing radioactive waste, right? So this is a vitrification process, but now it's being applied towards gasification. The output is what we're after, is synthesis gas. And if you just imagine organic materials, all of the plastics, all of the paper, all this stuff pretty much consists of carbon, hydrogen, and oxygen. That ends up coming out in the form of carbon monoxide and hydrogen, very reactive gases, flammable. You can burn them as fuel. They burn very cleanly if you wanted to. We're saying we don't want to burn them. So the first simple, it's very difficult because it's a hydrogen-rich gas, very difficult to transport hydrogen. So what we're saying is that the first simple molecule to make from that is methanol, which is, you know, there's a whole renaissance going on in the methanol market. Maersk is building ships to run on methanol, the big transport ships and whatnot. So it's a big global movement in methanol. So there's an important molecule here for a variety of things. But Eastman Chemical, for instance, that's their first chemical they make, and from there they make all kinds of other chemicals with it. And you see all the products that come from that. So we see in terms of the business output here, for a municipality, for instance, you get the tipping fee, because this is we would say, technology, implementation, and business model. The technology exists, implementation, put this at the landfill, and the important thing here is that because there is this robust element, it really changes the nature of the sorting process, where today we're sorting ourselves to death. What we can do then, I would say, is we can be selective, right? And we can be selective based on the immediate demand in the neighborhood, right? So someone shows up, they want to build lumber out of whatever, and they need so many pounds of material. You select to meet that demand, and and that's it, or more if you have other markets. But basically, you don't have to. If you miss one, it doesn't matter, right? So we could be selective, and it's not going to hurt if we miss things in this regard. So, all right, moving on. So this is a simple graphic. It comes from the Global Syngas Technology Council. I just took it right off their website and asked them permission to use it. Basically, it's what it shows, and I have a laser. Do I have a laser? Yes, I have a laser. Oh, did I just go backward? Yes, I did. Laser. Look, laser button. All right, so I just pasted over waste here, but they had carbon source, right? And so then you make syngas here, right? So I mentioned that Fischer-Tropsch stuff is over here. This is what the airline industry is doing today, and all over the world that's being done. So you could burn it for power. There's other applications as well. The hydrogen economy is coming on pretty strong. They're looking at this as well, big source of hydrogen. So what I'm saying is that from my perspective, from the consumer packaged goods market, this is all competition for this valuable resource. So what we're saying is that we want this stuff to end up down here, take it to methanol. So the municipality, they get the tipping fee, the stuff goes in, out comes methanol. The municipality then gets the benefit of the sales taxes on the methanol and extension of the life of the landfill, which is a lovely thing. All right, this is what a Generation 2 robust gasifier looks like at this point in time. Essentially, it's two gasifiers in one. This is essentially what we call a downdraft gasifier. FEMA in World War II actually put out plans and distributed it to people because they thought we would be restricted from petroleum. So you'll see in the Sears Roebuck catalog, there were cars that had gasifiers on the back of them. Anyway, very simple gasifier. And what it does is it just basically gasifies enough of it to keep the size of the important part of this thing, manageable and efficient. What doesn't get gasified here ends up down here. The temperatures in here can reach 5,000 degrees. So steel, aluminum, whatever's in there is going to be melted down into, we call this a molten bath gasifier. This one actually uses carbon electrodes, which is basically technology borrowed from the electric arc furnace industry, which recycles steel and whatnot. But essentially what comes out of here is the syngas from all the organic materials. Everything else is trapped in this molten bath, and we collect it as metal and glass, which are both inert and have industrial applications as well, right? This is a closed system. This is not like an incinerator with stuff belching into the environment. And essentially what we have here is all these materials Keurig just got fined in Canada and the United States for misleading consumers on the recyclability of the K-Cups. But we could throw it all in. They want you to peel the polymer-coated foil off and dump the coffee out, pull out the filter, and then put the little cup there. And then if you go to any MRF, they laugh at it, and it's like it goes right through the screen and goes right to the landfill. So anyway, all of this stuff is recyclable and would go through this. And what I want to say is we're not trying to displace other forms of recycling, right? What this is that robust element that changes the game. So what we say is that, we can be selective, and as developments happen and we have mechanical recycling doing its thing and there's demand for it, select those materials to get it out. There's a lot of work going on in depolymerization of PET. Eastman Chemical's building a $250 million plant in Tennessee, a $1 billion plant in France. There's other things like that. The beverage industry is obviously interested in the good PET there. And then, of course, pyrolysis is going on. All these are great. We love them all. But at the end of the day, there's a lot of stuff that we can't recycle, and that's where we are. And we can divert from incineration and landfill and get that back. Okay, so we made this little graphic. We kind of look at this as a keystone, right? It's funny because my daughter was doing biology and they were learning about keystone species. When you take one species out, take the wolf out of Yellowstone, then things go bad, right? So we think that everything will work better when we have a robust element in the recycling ecosystem. And so this is the type of investment we would want to make. It's readily available. We actually have a municipality up in North Florida in a county that has provided the land at their landfill for a project like this, and it's in the stages of early engineering work. I'm here actually so I started talking about this to the industry some years ago, and as I was doing it, people would come up and it's like, why aren't we doing this already? And so companies actually got together and they formed this consortium for waste circularity, right? And what they're doing is they're funding research, education, and outreach using the University of Florida's extension mission, which has great relationships with municipalities to bring, to educate. That's why I'm here. But I'm actually representing them today. And I'm not a member of the consortium, but they do fund my work now. And it is growing. There's a lot of interest in this area. So what I would say is that for more information and involvement in this, you'd certainly want to get in touch with the consortium, wastecircularity.org. And that's it. That's what I have for you.
Hello? So it works? Okay, thank you. Okay, well, I have a question. May I ask a question? Because, I'm from the EPA and I regulate things. And my first question is about the emissions from that, because you didn't mention that. Do you want to talk about that?
Well, I mentioned a little bit, but basically this is a closed process. It's essentially a carbon capture process. What goes in comes out. In a usable form. So the emissions are very low. In fact, Japan, which I believe has more stringent emissions than we do, there was a lot of work done there originally, and it was okay. It passes muster in Japan, so I don't see any issue here. And of course, we have gasifiers running all day, every day here in the United States, so they're regulated as well.
Okay, because you mentioned PFAS, and that's another thing that, I go, oh, you're going to put that in there, but that's okay. That's just
So
okay.
That's an important one. So PFAS, PVC, PVDC, important polymers in the packaging world. Basically, the halogenated stuff in a gasifier, as opposed to other processes like pyrolysis, which can produce dioxins, which is a problem. In this type of a process, they end up as the acids of the halogen. So PVC would produce hydrochloric acid. Typically, those are just neutralized with caustic, which converts it to salt, which then can be released to a municipality. However, we actually have a project right now sponsored by the Vinyl Institute and the Consortium for Waste Circularity to make use of those acids with materials at landfills to boost hydrogen output, which improves the yield of methanol. So it takes these pariah materials and actually improves recycling, which is kind of interesting.
Very interesting. Okay, I have another question here for Paul. So, Jake. Sorry. Oh, this isn't. Okay, yeah, probably. So Jake, you made it sound so easy with the paper recycling and the fiber recycling, and to hear that it can go through 7 times, like that paper bag can go 7 times through the system, or is it a certain thing that can go through 7 times?
Well, that's kind of a general rule of thumb that we use in the industry. Obviously there are certain types of fiber that won't make it that many times, but when you look at the composite of mixed paper, it's a little bit of everything. It's your cereal box, it's junk mail, it's a magazine. So all of those are kind of different fiber sources, but kind of as a very general rule, that's about 7 times. Yeah.
What about the little handle that I'm always on my Starbucks bag that seems to be like it would mess up a machine?
If it's made of paper.
Oh, a lot of them are.
A lot of them are made of paper. A lot of it's twisted paper. Yeah, and you'll see that's something else that you're going to see some paper companies evolve to. There was the pushback on plastic, and therefore there's a greater need for paper bags because they're very easily recovered. Essentially, if you look at the anatomy of a cardboard box, there's the outside part that you can touch, right? We call that liner board, and the inner part that does this is the medium. And so different basis weights of that. We use different ratios of the fiber. So depending on the weight that we're making that day or on that run, we can push different ratios of cardboard or mixed paper. So sometimes those little bits of contaminants they have less impactful, if that makes sense. Yeah.
So you really are figuring out your paper shake, your blender of shake, your ratio of things in there.
Believe it or not, it changes every day. My mill's been there for 30 years. We've learned a lot from it. The new mills are a little bit different. But the reason it's different every day is because what we get in for mixed paper is different every day. Contamination, which we've all talked about, it's a huge problem for us. I mean, we're the end of the line for recycling. When it comes to making another product, it's us. And, the contamination it just doesn't work in our system. The best picture that I can paint for you folks that'll drive the point home is imagine you just made a big bowl of pasta and you're getting ready to dump it into the strainer and somebody's put a piece of saran wrap in the strainer. Well, you don't get the water out, right? We have the same issue. It's exactly how it works for us. We're making pulp in that blender, and then when we go to drain that pulp to get it to the next step, to clean it and everything, if we can't get it to the next step in time, it creates problems in the system. So, yeah, efficiency for us, essentially.
What are your challenges, Paul, for the beverage containers that you've seen? What can you say about that?
Well, there's 3 of them that probably the main ones. One is the infrastructure. Some of the older MRFs can't pull it out as well. Another one is when I talked up there, some of the people are just laziness. They're not separating it correctly. And probably the third right now, which is a really big issue, is the new beer distributors. The new beers coming out, they're putting that plastic paper sleeve on that. I don't know if you've seen that. Well, they can't go to a UBC mill. That would create a fire. Imagine putting a piece of paper in a fire. When you're trying to put it out, what does it do? It flares up, right? So that is a big problem. But the association, the Alumni Association, is making everyone aware of it. So they're trying to change some things. So hopefully they'll get that handled. That's a big problem.
That seems like that'll be addressed. I mean, I can't imagine the beer makers like doing that.
Yeah, they're working on it. How many cans they push out, it makes it easier to do that paper sleeve on top. It's probably cheaper for them as well, but yeah, they're working on it. So that's a good thing.
Mm-hmm. And you mentioned making products out of the PET. Well, did you want to talk about that anymore?
Sure. Yeah. So there's a couple companies. 2 of them, Mohawk does for the PET bottles, does the carpet. I don't know if you guys are all aware of that. And then Unify does sportswear. So they shred up the plastic bottle, and actually there's a shirt on that table over there. If someone wants to hold it up, that's actually made from Unify out of plastic bottles that you guys are drinking right now. So you could feel it, pass it around. Yeah. But yeah, those. And then there's one other, HDPE color. There's a company up in Indiana called Polywood, and now they're making furniture out of it. Yeah, and one other, not to switch subjects, but Tetra Pak. We sit on the board for Carton Council, and now Tetra Pak, as you know, in Europe, they have a longer shelf life for milk, and it can sit on the counters a lot longer, so the U.S. is slowly starting to adapt it. there is markets now to recycle Tetra Pak, which is great. They have figured out how to take off the foil. They use the poly, and it's going in as like an SOP mix, which is cheaper now for the mills to use than buying, you know, a $200 short ton for SOP. So they're making strides. They're also using it for drywall now too, between for boarding purposes. So it's pretty neat. There's a lot of things going on. Yep.
So should we open it up? I'm not sure of the time. What time is it? Yes, time to do that? Okay, yeah. Sure. Wow, we got a lot of questions. How about we'll start here with this table?
I'm going to steal one of these.
Okay, Doug, why don't we start with you?
Yeah, this is a kind of a general question. The country of Sweden recycles 99%. They actually run out of garbage. Have you all looked at, are they ahead of our capabilities, or why are they so efficient and we're behind the curve?
Well, I know that they've been doing it a lot longer than we have. Europe is way ahead, but I can't answer that question. Who can?
Well, one thing I know, so my father's pretty big into waste energy as well, and we made some trips over to Europe. One thing they do different over there is they dry the trash before it comes in. I believe none of our waste facilities yet are doing that, so they're actually drying it up, getting it really hot, and it's becoming easier to separate. So that's why Europe is way ahead of the game. Plus, they find people over there, and if they're putting recyclable or food waste in the recyclable bins, they're getting fined, like a big fine. So they're really strict. I mean, Europe produces some of the most beautiful HDPE natural color PET. I mean, it's gorgeous. So that's a little bit what I know about that.
Thank you. And Dr. Welt, I thought your proposal was very simple. I was thinking about something very similar to that just the other day. Two questions. One is similar to a follow-up on what Ms. Alfano had said. Can you discuss whether or not, when you're burning parts of that, what, if any, this is giving off contaminants, carbon, methane, whatever that's giving off? And secondly, you said that at the bottom of that burner, all that was left was either glass or metal. I would assume some of that could be, heavy metals or causing stuff. Some of that, I just assume, has to be toxic ash. I can't believe it's all gas, glass, or metal. Could you elaborate on that? Because what you're saying sounds great as far as I understood it, but I wanted to inquire about the environmental impacts of both the burning and what's left, which I just assume has to have some ash.
Okay, so first of all, it's not burning. Like, there's no burning here, and the process itself is completely electrified, which lends itself to being powered through renewable energy. So there's not a burning aspect to this. It is a chemical process. In terms of the molten bath there, I mean, that technology was developed for securing radioactive waste. Right, so if there are metals, the things that go in there will ultimately be oxidized, and it's basically inorganic oxides, which is technically glass, right? So what comes out is glass. All those elements would be as their oxides trapped in a glass matrix, which renders them inert. Right now, inert in typical storage conditions, right? I mean, everything dissolves in everything. So if it depends on if you were going to store that or use it, right? You could use it in industrial applications. Like there's a company in Florida called Plasma Power that was doing this to produce power. They were doing some work in Alberta with the contaminated tar sands, producing a lot of glass, and they turned that into a fiber, right? A glass fiber insulation, very high value, and that's that. So the point is that what comes out in the bottom is effectively inert. If you wanted to store it, it's safe. If you wanted to use it, it's safe.
Thank you. For Dr. Welt, do you even know, what would it cost for a municipality to start using that system?
So ideally, so right now we've been talking to the chemical industry about offtake contracts for the methanol. We call this eco-methanol because technically it is recycled content methanol. And there's a whole bunch of stuff that goes on here, but basically this makes money, right? It makes money when the chemical companies understand that in order to sustain these processes, which they want because they need the recycled content to sell to downstream, right? Because all of the consumer packaged goods companies want the recycled content, and they want it in a way that delivers virgin quality, right? So, and that's what this does. So basically, we're working on a pricing formula, which we saw earlier today. There's a floor price, right? So there would be a floor price that would keep it sustainable, but by and large, it would be tied most likely to the market. You know, there's a spot price for methanol all over the world. So as that would fluctuate, the facility would do well. The capital investment of these things is on the same order of magnitude as an incinerator for similar capacity, and that's it. So the numbers work out at when the chemical companies agree to pay for that for that price. So it works out that way. So how does the municipality do it? I mean, basically, this shouldn't require government subsidies and all of that kind of thing. It may require initially some incentives or whatnot to get the community involved, but we actually have some major financial firms, the pension funds, insurance companies are sitting on about $5 trillion of investable assets. And frankly, when interest rates were so low, they were just dying for long-term, projects that would beat treasuries. So the money's there, the opportunities are there. I think it's really for the municipalities to really make the opportunities real.
Hi, good afternoon, Doctor. Can you please provide an opinion on the plastics to fuel? I know you touched on it before, but there's a few companies in America that are taking post-production plastics and turning it into fuel. Is it really sustainable?
Is it really sustainable? It is. Is it sustainable? It depends, of course, where the plastics are coming from to begin with, right? So if it's a fossil source, in my county, Alachua County, they were basically looking to ban any way that you could take plastic and burn it, right? And in that, they listed gasification. So I ran down there. I'm like, whoa, we could do other things with it, right? So they kind of put in the caveat that that any process that results in the ultimate burning of the plastics is not permitted in the county, but so long as you commit to the regenerative part, it is. So personally, I don't have well, I do have a dog in the fight, but I think any of the if we made fuel out of it, fine. Personally, I feel that way, but there are folks that are religiously committed to circularity, and the packaging companies need to see their products coming back as as materials, and that's really what we're advocating. And I think it's a more wholesome argument.
Hi there, thank you for your presentation. I also have a question for Dr. Welk. In terms of scalability, most municipalities have hundreds or thousands of tons per day of garbage.